Unit 19, Chemical Thermodynamics, and we'll start on page 59 and end at the top of page 62. So, thermodynamics tends to focus on whether or not a reaction will occur spontaneously and then in which direction. So, let's look at this example of a ball that's held up at a height, and its natural tendency would be to spontaneously fall downwards, hit the ground, bounce, until it comes to rest. And you'll notice that every time it hits the ground, the energy that's stored in it here is potential energy. As it's falling, it becomes kinetic energy. And when it bounces on the ground, some of the energy is transferred from the ball to the ground in the form of heat. And so you'll notice that the particles in the ground here would tend to vibrate with some heat. And then it would have less energy in order to bounce upwards, and it gets less and less until it comes to a full stop. So it's not going to be spontaneous for this ball sitting on the ground to all of a sudden start bouncing backwards into this original position. And so we would say that this process would be naturally spontaneous in the forward direction from here to here, but not spontaneous in the reverse direction from here to up here. So a spontaneous process occurs naturally by itself without any intervention and is irreversible, meaning that the process will never go backwards in the opposite direction. So for the falling ball, some processes occur naturally without any intervention. For example, the ball dropping on the floor bounces and comes to rest, and that process is spontaneous. The potential energy of the ball turns into kinetic energy as it falls, and then when it hits the floor, it transfers heat into the floor. The reverse process, where the ball is at rest, for it to suddenly start hopping around by itself would never happen, so that reverse process is not spontaneous. So why is this spontaneous? It's the natural tendency of the universe for energy that is organized to become disorganized. That's the second law of thermodynamics. This figure shows how organized energy in the motion of the ball is converted into random motions of many atoms in the floor when the ball bounces. So this diagram is showing us that at the point at which the ball hits the floor, some of the energy is transferred from the ball into the particles in the floor in the form of heat. And you'll notice it creates a little bit more of a disorganized feel in the particles in the floor. When the ball hits the floor, organized motion of the ball goes into the motion of the molecules in the floor. There are many molecules in the floor that all act independently. Energy quickly becomes dispersed in a random and chaotic manner. The reverse process is never observed because it is non-spontaneous. For the process below to occur, energy in random chaotic motions of molecules in the floor would have to collect and move toward the ball. Molecules do not work together in this way, so the reverse process is never going to occur. Meaning, the ball is not going to draw energy from the floor, or the floor is not going to provide energy into the ball in order for the ball to bounce upward. That reverse process is not possible.